to show it again and distribute it. And so by participating, you're agreeing that your contributions become part of the recording. And so,
but do participate.
So yeah, so do participate. Absolutely. So this is really exciting for me because this webinar is going to be a conversation between me and Danny Kaplan. My name is Donna LaLonde, and I'm at the American Statistical Association, but I have the pleasure of serving with Danny on the StatPREP leadership team. And Danny is, as many of you know, probably the foundation of StatPREP, and so he has contributed a lot to the ongoing work. And most recently is the author of A Compact Guide to Classical Inference. And in this conversation, we're going to talk about why Danny took the made the contribution to write this book. And hopefully you will be willing to engage. We will try to watch the chat, so please feel free to ask questions using the chat feature. And at the end, if we have time, we'll open it up for questions, just kind of free form. So with that, I'll ask Danny if he wants to add anything to introduce himself.
No, I'm Danny Kaplan. I'm at McAllister College in St. Paul, Minnesota.
Great. So Danny, we're going to talk about the Compact Guide to Classical Inference. And I have some questions that I want to ask you about. And the first is, why did you write the Compact Guide? Why now?
Why now? For the last 3 years, when we've been doing StatPREP summer workshops, we've had a breakout session. And in the breakout session, I try to show people that all of the tests that they're doing in intro stats are really in an underlying way the same thing, that they're all regression. And I don't think I was very successful the first year, maybe a little more successful the second year. And then last year, people seemed to really clue in on it because I changed the way I presented things. And they asked me if this was written up. They were surprised to see the simple formulas that maybe we'll see later, but these very, very simple formulas that handle all of these cases. They were surprised. They wanted to know where it was written up. And it's written up in StatPREP stuff is where it is. So a couple of people, Nick Horton, especially George Cobb, encouraged me to write it up for a journal like Journal of Statistics Education or the American Statistician. And I wrote such a paper in July and I didn't like it. And then I revised it in October. And I thought, you know, the people in StatPREP, when they run into this formal language that you have to use in a journal article, they're not going to find it compelling. So I challenged myself to write a short book that I hope will be more compelling than a journal paper and that can be more discussed, say the kinds of things that you need as background that journals don't let you put in because many people already know them. And really what I'm trying to do with it is to present the classical settings of statistical inference, you know, the difference of two means, difference of two proportions, slope of a line, and even the problem that's handled by chi-squared, present those in a much more compact, a tighter way, and I think a simpler way, and certainly a more unified way. And the reason to do that is partly because I think unifying it makes it easier for students. We'll have to find out if that's actually the case, but also because there's so much else we have to cover in intro stats. And we need to carve out some space to talk about some of the things they talk about in the Gaze report as being important. For example, multivariate thinking would be an example.
So Danny, you mentioned that there are a lot of topics to cover in intro stats. And so I think from the perspective of students, that's probably what makes the course, the standard approach, difficult. But are there other aspects of the standard approach that you think make it difficult?
Yeah, I do. You know, Donna, it's not just students who think of many courses. Every year, we ask the StatPREP participants, what are their leading concerns about the statistics course they're teaching? And we offer them a set of options. They can choose their leading ones. And always, people are choosing too many topics. It's just too many things going in too many directions. And for students, that shows up as having to remember which technique do I use for this kind of problem, and making categorical errors like applying linear regression to problems that might be chi-squared problems in the textbook. So that's one thing, is just too many problems is a serious difficulty, and it crowds out other important topics. Also, presenting these things as formula, students, by and large, in fact, most everyone, is not very good at reading formulas and parsing them. Mathematicians are particularly good at it. So it's easier for them than it is for many of their students. And there's a kind of cognitive disconnect that makes things difficult. And the disconnect is this: all of that statistical inference is about sampling variation, is about random stuff that goes on. And when you present a formula, it's completely deterministic. And so students are trying to get their heads around how a formula that always gives exactly the same answer can describe something that's random. So that's I think, a big thing that makes the course hard. And just to say that it is hard, when I talk to instructors about what topics they hope to cover and what topics they do cover, always ANOVA is, maybe you get to ANOVA. Multiple regression, not so much. And those are important topics for making sense of the world.
So Danny, you may remember this, but I remember when David Morgenstein was giving his presidential address at JSM, he actually talked about the role of the statistician is to be the person at the party that has to receive, oh, I took that course and it was terrible, right? That it was really hard. So that kind of, so I guess, the reputation might be just that statistics is tough. So how is it that the compact guide approach is going to make it less difficult? You want to say a little more about that?
Sure. Well, so I'm hoping it's an empirical question whether it's less difficult. And always, for someone teaching something the first time, it's more difficult because you're used to another way and you've adopted that way, and you've tuned yourself to get favorable responses from students, or knowing glances from students about what you're doing. So the first time is always hard. I think in the long run, it's easier because, one, you don't have all these different settings. Means, proportions, slopes. I know it sounds odd, but they're all the same thing. So you have fewer settings, exactly the same formulas apply to all of them, and also apply to ANOVA and multiple regression. And they're really simple formulas. So I think that's one thing that makes it easy. Another part of making it easy is to recognize that there's a lot of excess calculation in the statistics course. And I think here the recent statements by ASA have been tremendously liberating, because they make it clear what professionals think is important. And one thing that they don't think is important is the third digit in a p-value. Right? They're trying to de-emphasize p-values, or as they say, move to a post-p less than 0.05 world. And those p-values, the calculations of p-values, inevitably get wrapped up in these complicated tables that have much more detail than anyone could possibly need. They get tied up with sort of pseudo issues like one-tailed tests. You don't need to do this, or with specialized things like the unequal variance t-test. It can be much simpler than that and still serve the purposes that professional statisticians are looking for.
Danny, it sounds like you're suggesting that we discard some dated topics that and maybe spend more time on developing that conceptual understanding with students. And so, do you want to say a little bit more about topics that you I mean, you've mentioned the sort of p-value and statistical significance, but are there other topics that you think the modern person needs to be focusing on?
Yeah, I certainly do. You've said dated topics, and I agree that many topics are dated, and I'll talk about that. But you know, in the mathematics tradition, topics are never dated, right? So mathematicians are happy to talk about calculus concepts from ancient times. And that's part of their culture. But in statistics, we also have to deal with the demands of the modern world. And if we had infinite time, then you could cover every topic, give someone really an in-depth view of the whole history and field of statistics. But we don't have infinite time, and students don't have infinite attention or energy. So in fact, what we do is to present statistics in a historical way. So an early topic often is the correlation coefficient. And the correlation coefficient is from the 1880s. It was an important part of the development of statistical concepts, but it was not the end of the development of statistical concepts. And things have moved along to where we can do without the Pearson product moment formula for the correlation coefficient. That's one example of a data topic. Even more data, chi-squared. This was introduced before the correlation coefficient. And there were arguments for 20 or 30 years about how many degrees of freedom and such. And you see those arguments play out in statistics where you're introducing these things like degrees of freedom. But chi-squared can be better addressed with modern techniques. And the modern techniques are modeling techniques. In machine learning, they call these classifiers. But you can think of it just as regression with a categorical response variable. And then you get an effect size. You don't get that from chi-squared. All chi-squared produces is a p-value. And allow you to include covariance. So those are some important new topics, not so new. 1910 already, covariates were being introduced, but learning how to adjust for other variables. And also our statistics course is rather informal when it comes to data itself and how data are stored, how data are manipulated or wrangled, right? That's not part of the classical tradition. That was sort of something you learned on your own and you wrote things down in your eccentric way in a lab notebook. That doesn't work with the present demand for data. There's a lot of discipline to how to handle data, and it makes it people much more powerful at accessing and dealing with data. So some of these old concepts and tests, I think we can move along. They were introduced at about the same time as the automobile was introduced. The correlation coefficient is the same year that Benz invented the internal combustion engine, and the t-test is the same year that the Model T was released. And ANOVA was, I think, pretty much the same year as the Model A Ford was released. And those are great cars. I love to look at those cars. But take a car like that on the highway, and your life is in your own hands. They were designed for other purposes. They were designed to go on the roads that existed at the time, which typically were not paved, very few paved roads. And of course, now cars serve another purpose, just as data serves another purpose than it did in 1905. So yeah, I think there are topics that are dated, and by unifying them, putting them in a modern framework, we make it both more systematic, simpler, and shorter.
Actually, sort of two follow-ups on that, and I think the first one is you've talked a lot about, or you talked a little bit here about data wrangling, and sort of the modern need to be able to deal with data. So I think a question I'd like to ask is, do you need computers to teach with the compact guide, teach in the way that the compact guide is proposing?
Right. So the compact guide is not about a whole statistics course. It's about a part of the statistics course. Often it seems like the main part, but just a part, which is statistical inference, and to some extent, descriptive statistics. And I think that computing is essential. It's not, I think. Computing is essential for modern uses of data. And I think it makes a huge amount of sense for statistics to be the forum in which students are introduced to kind of scientific computing as opposed to email and such, which they're already masters of. I think that makes a lot of sense. But there are many instructors who don't want to do this for reasons that are both good and bad. The good reason that you hear a lot, especially in a two-year college context, is that students don't have access to computers. And so I wrote the compact guide so that you could teach inference without any computers. Now, you might need a computer to prepare a handout or a graphic that students are going to mark on, but you don't need a computer, you don't need a graphing calculator. The calculations are so simple, and there's no probability tables that you need. And so that aspect also doesn't have to be computerized. I think that using a computer, teaching inference by randomization, I think those are great things to do in a statistics course, but not everyone is there. And so I thought I would cover the inference they're familiar with, those classical settings, but in a way that uses formulas, very simple. I think we'll see them in a little bit. And lets us cover lots of different settings. Let's bring them together. So no,
I'm gonna hold off on the follow-up that's on the slide about the StatPREP resources, and let us talk about those in just a few minutes. But I guess I will ask. So you've described the compact guide as not a textbook. So do you want to say a little bit more about the role you see it playing as a curriculum resource?
Right. So when you look at it, you'll see it's not a textbook. It doesn't have exercises. More important, it doesn't cover the whole of statistics. It's just about this one segment, inference. I really wrote it for instructors so that instructors could get a fresh look at the statistical inference they've been covering. Because it's genuinely hard after teaching about t-tests and differences in proportions and differences in means, it's genuinely hard to get into another mode of talking about models. And so I thought writing something for instructors, but that is almost something that would be suitable for students to read, would help instructors to see both this new perspective and how they might present it to students. I think if there were to be a textbook, it's going to have to come out of the experience of teachers using this in front of real students in real settings. So that would be premature right now, because the approach that's introduced in Compact Guide is genuinely novel.
Before we talk about the resources and maybe dig into a little bit of the content of the Compact Guide, do you want to describe how it's going to be released, what serial publication means, as the blog post indicated on the StatPREP website?
Right. So the StatPREP leadership group discussed how this might be presented. A book, even a very small book, is a lot to bite off, especially December 10th, exams are coming up, or you're in the midst of exams, and then you're on break, and then you're back at teaching. And so we thought it would be too daunting for people to face a whole book. And releasing it 1 or 2 chapters at a time, and they're short chapters by and large, would make it easier for people just to take 10 minutes to look it over and either move on, or they might have questions and want to do further, want to participate in the discussion forum that we have on MAA Connect. But we thought we would spread it out over time. And then as we learn people's responses, we might be able to do webinars or discussions like this to make things clearer, to show some examples.
Okay, so I think that there's a way, if folks who are, especially those who are participating in this webinar, if they want to see the whole book, you'll give us the how to do that at the end when we show the URL.
Okay, yes, I'll do that.
Okay, very good.
Easy, yeah.
So as we were talking about preparing for this, you suggested that there are some StatPREP resources that folks might want to pay attention to or look at again if they haven't looked at them, that might help them dig into the compact guide. And so, do you want to spend just a little time talking about those resources? And
yeah, let's do that. So our experience with StatPREP is that for instructors to work with actual data, it is helpful to have computers. And it's really helpful to let students interact with data, to do it actively and be able to explore. And so we put together a series of web browser apps, I guess you call them, which we're calling little apps. And all of there's a screenshot from one of them up on your slide there. That's the linear models little app, which is particularly relevant to the compact guide. Every little app is based on a plot of a response variable against an explanatory variable. I can't see the variable names on the little image, but as a response variable versus an explanatory variable, the responses can be categorical or quantitative, same for the explanatory variable. That's already a different way of thinking of it, right? Not 2 groups and calculate the mean or proportion, but 2 variables. One's a response, one's an explanatory. So all these little apps let you play. It can be fun, I think. Play with data and statistical annotations on data. So you see 3 such annotations on this graph. Obviously there's a point plot, a scatter plot of data points, but you see there's a regression line, nothing special about that. But you see these marks off to the side. That's something, an annotation. The red ones are the raw data, just the response variable. And the black ones are the values of the model at the data points. And those I-beams mark off 1 standard deviation, or I guess 2 standard deviations in both of those. That's the foundation of inference. And so just having those 2 little annotations and knowing n will get you all the way through inference. And then another aspect of the little apps is that there's a button. It's green, you can't really read it. Whenever you press that button, you get a new sample. And so it's very natural to see sampling variation. As you sample from a much larger data set, over and over again, you can see that line jump around, or whatever statistic it is. And so we've got little apps for making point plots and showing people conventions for making point plots, for looking at proportions as models, for doing, this one is the linear models one, and it lets you play with response and explanatory variables, covariates and such. But all of them, all you need is a web browser, and then you can interact with data. And we're constantly expanding the data sets available. So I can't really see which one this is, but we have some with 100,000 cases and 70 variables, for example, about births in the US. We're trying to make them serious data sets that students can seriously explore. So that, I think, is a great resource and doesn't require installation or anything like that, just links. There's a link. I see you have a link to this one at the bottom of the screen.
Right, and I think, I'm guessing that the folks who are participating in this webinar know that at the StatPREP website, which I'll show the URL at the end, all of the little apps are also listed and easily available. So that's a great resource.
That's right, and also there are sort of lesson ideas, different topics you can cover with the little apps. We're trying to get a small number of apps to cover a lot of the concepts in statistics. It's that much easier when you unify the different settings for inference. There's a t-test app, for example. And I think if you play with the t-test app, you'll discover that a t-test is not actually that difficult, and that the t part of it is not usually that important. So these are things where you can discover statistical concepts on your own.
And I think you mentioned this, that it doesn't require any installation and really designed to be used in the classroom. So you, if students have access to a Chromebook or some computing device.
Right, a student or an instructor, if they want to do a demo. We're working on a new generation of them. And so taking the best ideas from those that are out there now. And I'm hoping that the new generation will work nicely on a smartphone screen.
Okay, nice.
Not every student has a smartphone by any means, but some do.
For sure.
And
so, yeah.
I don't know how students can do this with the mini screen, but I'm trying to make it so that they will be doable on a telephone screen.
Yeah, I need a magnifying glass for my magnifying glass, but you know, they seem to younger eyes, I guess. So just to let people know, and we'll come back to this, the URL is available on the StatPREP website. So if they don't catch it at the end, they can definitely go to the StatPREP website. And this is a quick look at what's inside. I don't know, Danny, if you want to take any time to talk about the organization and the chapters, or
yeah, I'll do this briefly. So the ones that have been released are the preface and this chapter, What is Classical Inference? And I think one thing that someone pointed out about that What is Classical Inference chapter is that it does not draw on the idea of a population, which is sort of the conventional way to talk about inference, that we're reasoning from data to the population. There's a lot of problems with that perspective. And then chapter 2, which will come out, I guess, later this week, is about data and very basic things about data, but you have to have some vocabulary about data so that you know what different kinds of variables are. 3 is how to measure variation. And one thing that's really, I think, unusual about the compact guide is that we use the variance to measure variation. And chapter 3 gives, I think, a pretty neat way to explain what the variance is, even if you don't have the mean or you don't have the standard deviation. There's a simple explanation of variance. And then in 4, we're introducing this modeling paradigm, a kind of modern way to do things. And then we're adding layering some information on top of that in chapter 5 and chapter 6. You know, this is maybe typical. Everyone's heard of degrees of freedom. Well, I think it's easier to explain things if you put the degrees of freedom off to the side for a little bit, talk about the sample size, which everyone gets, and then the model, which is, I'm calling degrees of flexibility. So degrees of flexibility is about the model, the sample size is about the data. And then introducing things like how to measure the relationship between 2 variables as an effect size, and then doing F and F, I think chapter 8 got left off of this slide. Chapter 8 is kind of the central chapter in the book in terms of inference. And then 9 builds on that. And then the remaining chapters are really meant to give a background to instructors, not necessarily something they want to cover in their class, maybe, but so that they can see, for example, what's behind the ASA statements on statistical inference. Chapter 10 gives some history of that. And then chapter 14 at the very end reminds us that this is only about sampling variation. Sampling variation is not necessarily the biggest item that needs to be considered when working with data. Back in the days when N was 3, maybe sampling variation was the biggest thing, but that's not the case with larger N. And it helps to emphasize that inference is just one topic of importance in statistical investigations.
And I think that you are going to give us the compact inference in 2 slides, right? So
I'm gonna, yeah.
Everything we always wanted to know.
So I said it was compact. So this is not the way it's presented in the guide. It's a more systematic layout. But here's, I think, the same screenshot we saw earlier of one of the little apps, and I still can't actually read it. But again, you have some data. There's a point plot. All the plots have data in them. An annotation, a statistical annotation. In this case, the linear regression line. You know, it's not so important that you calculate the linear regression line exactly. And I think it helps a lot for students just to look at the data and sketch in models. And then talk about why their models are different, as opposed to, here's the criterion of least squares. When we optimize this, we get so-and-so. That's not needed until you have a way to talk about variation. And then for the inference techniques themselves, for the formulas, the 2 crucial quantities are the variance of the response variable and the variance of the model values, the ones that you'd read off of that line. And the basic statistic that's in the compact guide is the F statistic. And it's not done in the way that many textbooks start with F in ANOVA, one-way ANOVA chapters with sums of this and sums of that. F is just a ratio of 2 things: how much variance the model gives you and how much is left over. And you take that ratio, you multiply it by n-1, you have F. It's the same F that you'd get in your ANOVA chapter. And then F itself can be used directly for inference. So a hypothesis test can be introduced as simply as, is F bigger than 4? Right? And why 4? Well, that's 2 squared will be the hint about why 4. But that's really all you need for n bigger than 10, 20, pick a number. That's all you need, is F bigger than 4, and is it much bigger? And then converting to p-values, I don't think that's strictly necessary for statistical work, but it's trivial to do. You can do it with a graph. You don't need a computer or a table. Look up F, convert it to a p-value. And then the confidence interval, this is the part I like the most. The confidence interval, or this is the margin of error, I should say. I don't know why I wrote confidence interval. The margin of error is just root 4 over F. And then you multiply that by the effect size. No standard error. There's no pooled variance. There's nothing like that. It all comes from F. So with these 2 formulas, you can do basically all, and being able to draw those kinds of models that we saw on the last slide, you can do all of inference. And you can do a lot of inference pretty well by estimating things by eye, like the length of those standard deviations in the previous slide.
So some important URLs. I have a couple of concluding questions, but I'll put these up so that folks can see. And Danny, maybe now would be the time, because there was a question in the chat about, yes, I want to see the whole book. So what should folks do if they would like to see the whole book?
Okay, so that URL at the bottom, github.io compact inference, that's as we release it serially. If you want to see the whole book, and the last 2 chapters are incomplete actually, but if you want to see the whole book, just add the word private after that. Maybe I should have said whole book, but I made it private. It's not private, you're welcome to look at it, but just as a way of not being too imposing on people who only have a few minutes to try to get a handle on things as they're going. So just compact inference / private, and that'll take you to the whole book.
And I wanted to circle back just to the ASA statement on statistical significance and sort of the post, what a course would look like in the post p-value world, and just make, I think you've covered it pretty completely, the comments that you might have wanted to make on that, but just thought I would check in to make sure that that question got covered sufficiently in terms of what guidance the compact guide might give.
Yeah, well, so let me go back there, because I said the liberating thing about this ASA statement is that it tells us what professional standards are, what p-values are for, and what they're not for. And so that gives us the ability to think about what we want to teach, which topics are important, without, just keeping one eye on the textbooks from 50 years ago or longer ago than that. We can look at things from a modern perspective. The US Conference on Teaching Statistics, US COTS, was held in May every other year. And the whole theme of that conference was the post P less than 0.05 world. And I think people came away from it not quite sure what they might do. And one of the big problems is that so much of the course is about calculating P. And so the only way it's easy to respond to these challenges posed by the ASA statement is to ignore them. That's the easiest way to do things. And that's, I think, what people are going to do until they're comfortable doing something else. So it's hard. It's hard to know how to respond, because it's abandon statistical significance, I think, is a quote from one of the statements. That's a pretty strong statement. It's well reasoned, but it's a pretty strong statement. And so I think I've been able to exploit the information that the ASA has given us to sort of put p-values in their place, to say, this is how much you need to know to calculate a p-value, and you don't have to imply that it tells you something exact. P-values tell you something vague, and they may not be telling you what you want at all. Effect size might be more important. So this compact guide gives you just what you need to know about p-values, and then the focus on effect size. That's the spirit of it.
And so, well, I have one final question. So I wanted to invite folks to put questions in chat if they have them, or actually, I think at this point, unmute themselves and go ahead and ask the question. But my final question is that, okay, so I'm reading the compact guide, and I'd like to know what you would suggest that I do next. Now, in terms of changing my teaching.
Changing your teaching.
Potentially.
Okay. So first, just to acknowledge, changing is hard. And doing it in front of a live audience without a net can be anxiety provoking. But if you're going to change, eventually you need to deal with that situation and just acknowledge that you can't always be the best teacher you've ever been when you're teaching something that's in a new format or a new topic or a new perspective. But where to start? I think the usual conventional intro to stats, people are familiar with teaching it and they're good at it. I think that's a good starting point. And I would take that up through the confidence interval on a sample mean or on a sample proportion. I take it up through that, but I wouldn't go on to hypothesis testing yet. And at that point, I'd suggest that you introduce this idea of models and how the models correspond to the data, maybe exercises in sketching models over data, and then interpreting the models. You know, it could be the slope of a regression line is telling you the relationship, or it could be the difference between two groups in the model values is telling you something about the relationship. But focus on models and their kind of, I'll say, naive interpretation. This is a slope. Oh, it's a non-zero slope. These variables must be related. And then introduce this idea of model values, which is just evaluating the models at the value of the explanatory variable. Model values, and then the actual response variable, the raw values if you want. Introduce measuring that variation, and then you're ready to go. You're in a position to do R² immediately. It's just the ratio of those two variances. You're in a position to do F immediately. And then once you've done F, confidence intervals come basically for free because they're directly derived from F and the effect size. So I'd say go through confidence intervals on this one sample mean, I guess is what it is. But don't do one sample t-test, and don't worry about the probability distribution, the t as opposed to the z distribution. You don't need that yet. And then leave off on hypothesis testing until after you've introduced F and confidence intervals. And then if you want to talk about P, I imagine a lot of people do, but if you want to talk about P, that's a simple transformation. But there's no point talking about P before you've introduced F. And then once you've introduced F, P is a really simple lookup. One graph will do it for you. And then you can go on to other topics that you think are important. Looking at multiple regression. All the inference is there already. It's the same F. Looking at one-way ANOVA, two-way ANOVA, it's the same F. So you're all set up for doing that. And it's still in terms of the model values and response variables. And you can talk about experimental design. You can talk about study design. You can have people read papers. You can have people look at the ethics of big data in modern world. There's all sorts of machine learning you could do, I guess, if you were a technical kind of person. All sorts of things you can do. And if you can save yourself a couple of weeks on inference and still have students get it, and I think they'll get it better this way, but still have students get it, then you've got some room to talk about new things. Wrangling might be what you want to talk about. Graphics, modern graphics. That's how I'd suggest people start.
That's great. So I'm not seeing any questions, so I might just take this opportunity to remind people that there's a blog post on the StatPREP.org website that also has the link to the compact guide, and MAA Connect, which is a new online community discussion resource. There'll be ongoing discussion about the compact guide, and then I've had so much fun doing this. I'm hoping that Danny and I get to have more conversations about the chapters as they get released, because that would be really fun to talk about. So I will say thank you, and these are our email addresses. And I'm guessing, Danny, that if folks had questions as they were reading the book, they could obviously go to MAA Connect and post, but they could potentially reach out to you directly via email.
Absolutely. Write to me, post a question on MAA Connect. Maybe if you write to me, I'll post it on MAA Connect. And we also at StatPREP have 2 times a month, we have what I'll call consulting days. And the next one is, I think, Thursday, December 17. It's on the StatPREP website. And you can pick a half an hour or an hour slot at any time during the day, 7 a.m. to 7 p.m. and just ask anything you want to ask. And we'll try to help you out with it. So if you want to talk about compact inference, that would be delightful. If you want to talk about anything else, that would be great too.
And say again, Danny, how folks would register for or get access to the consulting hours?
So there's, if you go to the StatPREP homepage, there's a blog entry that gives a link.
Okay.
To consulting days. And that will bring you to Google Calendar. And you might have to page forward to December 17th in that calendar, but then you'll see all of these little slots listed. Just click on one and things happen automatically. I get told and it's reserved, ready to go.
Very cool. Well, there's a lot of thank yous in the chat, and there's with an exclamation point. I like your teaching plan. So so I think, unless I'll give folks another minute or two to think about questions.
I have a question. I'll ask myself.
Okay. Yeah, go ahead. Go for it.
If this is right, how come I haven't seen it already? And I was also surprised that those simple formulas could do the job, or certainly the confidence interval formula. But I did an exercise for myself. What is a minimum set of concepts that you need to be able to talk sensibly about statistics? And I don't mean to be able to talk about the concepts that everyone talks about, but to be able to master the major concepts, core concepts in statistics. And because I looked at things that way and I was trying every step, get rid of this, get rid of this. Can I get rid of that? No. Get rid of this. As I trimmed things down, the program became much less complicated and things fell together. And really all I did was to rearrange the order of calculations that are done traditionally for regression. But that rearrangement comes really simply. It's very rewarding to me. So I think it is right. I think you haven't seen it before. And I hope that you'll like it.
Well, that's a perfect way to end. I hope folks will take the time to go read the chapters that are out there, or look at the whole book. I admit that
there's a question in the chat.
Oh, exam question ideas.
Exam question ideas. So even if you teach with a computer, I'm a big fan of not having students use the computer during the exam. And one reason is evident to all instructors, but because this is such a graphical approach, you can give students a plot of data and have them go through, just with by eye and pencil, go through the calculations. What is this variance of the response variable? It doesn't have to be exact. What is the variance of the model values? Again, doesn't need to be exact. What's the ratio? What's F? How do you interpret that? So because there's just those 2 formulas, it's not a matter of the cognitive switching between different kinds of tests. So I think you can give tests that are about interpretation and calculation by eye. And of course, if you want to have them use computer commands, you can do that. But I think drawing on graphs is a great way to learn and to show that you've learned.
It was a great question. And I'm not seeing any others. Thank you. Well, this has been a lot of fun. Thanks everyone for participating. And we look forward to the conversation on M&A Connect. And I'll remind folks that Danny offers the consulting hours December 17th.
17th.
Thursday. Yep. Okay.
Well, thanks
Great.
all for coming.
Yeah. Thank you very much.